Hey, greetings everyone. Today's topic is in the pair of linear equations. We will review two topics, two methods of solving this pair of linear equation, that is the substitution method and elimination method. So let's look at a substitution method, right? I can tell both the methods side by side, so that way it will be easy for you to remember, right? So let's look at substitution method. Take any pair of equations. So for example, I'll take this, right? So 3x minus y equal to 3 and 9x minus 3y equal to 9. Okay, now we need to solve this equation using the substitution method. Okay, so substitution method, by the name itself, we can know this is substituting one variable in place of other variable. That's the substitution method. So how we can do this? So we can do this by using like there are two equations, right? Let's say this is equation 1 and this is equation 2. So what we can do is, from this equation, can I say from the first equation 3x minus y equal to 3, right? So can I say y equal to 3x minus 3? Can I say that? So I'm taking y to this side and sending 3 to other side and then flipping it. So y is 3x minus 3. Now this value of y, if I substitute in the second equation, so this is the value of y, right? Now substitute this value, substitute y in equation 2. So then the equation 2 becomes everything in x variable, right? So what is second equation? 9x minus 3y equal to 9. Now 9x minus 3 times of what is y? 3x minus 3 equal to 9. So now 9x minus 3 into 3 is 9x plus 9 equal to 9. So 9x gets cut. So basically there is no solution for this. So you are not able to find x value here. That means there is no solution. So when we don't get any solution, if these are parallel lines, so can we check a1 by a2 and b1 by b2 for this? So a1 by a2 equal to b1 by b2 equal to c1 by c2. Yeah, it's not maybe no solution, maybe infinite solutions also. Let's see. So what is a1 by a2? It is 3 by 9 equal to minus 1 by minus 3 equal to 3 by 9 or minus 3 by minus 9. So if you look at everything, we are getting as 1 by 3. So that means these are coincident lines. This will have infinite solutions. Any value for x and y will be satisfying for this. So these are like coincident lines. So all the examples that we are taking, we are not getting a solution because the choice of lines is not that great. So let me take another example where we can get a solution this time. Okay. So let's consider another example. So let me see what kind of example I can take. Okay. So we'll take simple. Okay. X plus y equal to 14 and then x minus y equal to 4. So these are the two equations. Let's see. Now compare this a1 by a2, b1 by b2, c1 by c2 beforehand so that we know whether we will get a solution or not. So for this to have a solution, what we need, a1 by a2 should not be equal to b1 by b2. So what is a1 by a2 here? 1 by 1 is 1. And here 1 by minus 1 is minus 1. So which is not equal to. So this should have a solution. Okay. So this time we will get a solution. Okay. This is equation 1. And this is equation 2. So from equation 1, take any variable. For example, x plus y is 14. take y. What is y? Y becomes 14 minus x, isn't it? Now, substitute this value in equation 2, right? This is substitution method. Substitute y in equation 2. So what is equation 2? X minus y is 4. X minus y is 4. Okay. So what is the value of y? So x minus the value of y is 14 minus x, that equal to 4. So x minus 14 minus of minus x is plus x, that is 4. Now x plus x is 2x minus 14 is 4. Then what is 2x? That 14 comes this side. So that becomes 18. So 2x becomes 18. Then what is x? X becomes 9. So if x is 9, substitute that in this equation or any equation. Or what is our second equation? X plus y, sorry, the first equation x plus y is 14. So x plus, substitute the value of y. Sorry, no, we got x, right? So then substitute the value of x so that we get the value of y. So 9 plus y equal to 14. Then y is 14 minus 9. Then y is 5. Therefore, this has a solution, unique solution, and the value of x is 9 and value of y is 5. So 9 comma 5 is the solution for this pair of linear equations. So this is the substitution method. Okay, so the substitution method is basically from one equation, you find either x or y, and that value you substitute in the second equation. Okay, that is the substitution method. Now let's move to the elimination method. So let's see how that elimination method works, right? So eliminate, by the name itself, you can sense we are trying to eliminate something, right? So what we are trying to eliminate? We eliminate, there are only two variables, x or y. So we'll try to eliminate either x or y. That is our elimination method. Okay, so let's take one example. Here also same thing, right? Okay. Now let's take this. I need a good example for the elimination method. 1 minute. Yeah, let's take these equations. 9x minus 4y equal to 2000. And then 7x minus 3y equal to 2000. So these are the two equations of variables x and y. Okay. Now let's see how to do using the elimination method. So we have two equations. Eliminating means we need to eliminate either x variable or y variable so that we can find the other variable. Okay, so two equations. Here I will give one hint. So in elimination method, what we need to do is, first let's identify which variable we need to get rid of or eliminate. I want to eliminate x. Okay, so if I want to eliminate x, let's look at the x coefficient in both the equations. So for the first equation, I have the x coefficient as 9. And in the second equation, I have x coefficient as 7. So what I will do is, the first equation, I will multiply with the coefficient of the second equation, which is 7 in this case. Understood? Now, for the second equation, I will multiply with the coefficient of x of first equation, which is 9. So what will happen if we multiply that entire equation? 9 into 7 is 63. In the second equation also 9 into 7 is 63. So when I subtract, that x term gets, I can eliminate x by subtracting both the equations. So that's the main purpose of elimination method. So the thumb rule or the hint for the elimination method is, whichever variable x or y you want to eliminate, look at the coefficients of x or y, multiply the other equation with that. Okay, so if you want the first equation you need to multiply with the second equation's x coefficient, and first equation you need to multiply with the second equation's x coefficient, vice versa, right? Now, so I'm multiplying this equation, the first equation, with 7. 7 is the coefficient of second equation, coefficient of x of second equation. Now, 7 nines 63x, the entire equation you need to multiply, minus 7 fours 28y, that equal to 7 twos 14,000. Okay, so this with 7 I have multiplied all the terms in the equation. Now, what is the second equation? Now the second equation will transform to 9 sevens 63x minus 9 threes 27y equal to 18,000. Now, these two equations, what I'll do, I'll subtract them. Okay, when I subtract from this and this, the signs will get reverse, right? Now, 63x minus 63x gets cancelled. So now minus 28y plus 27y, that means minus y. And 14,000 minus 18,000 is minus 4,000. So minus minus we can take away. So y is basically 4,000. How simple it is, see. If you want to even do with the substitution method, it will take a lot of effort because you have coefficients here. So if you want to take y, it is difficult, like 2000. In the first equation, if you want to take y, so then 4y becomes minus 4y becomes 2000 minus 9x, and this minus 4 you need to send it down. So it is little difficult. But in the elimination method, even though if you have coefficients, it is easy to eliminate x or y variable by multiplying with their coefficients, opposite coefficients. Like for first equation with second equation coefficient, and for second equation for the first equation's coefficient. So now I got y. Now substitute this value of y in any one equation, right? So for example, I'm substituting in the first equation, 9x minus 4y equal to 2000. Now 9x minus 4 into 4000 is 2000. Now 9x minus 16,000, right? So 9x minus 16,000 is 2000. Then 9x becomes 2000 plus 16. Then 9x is basically 18,000. Then x is 18,000 by 9, which is 2000. So here x is 2000 and y is 4000. At first, when I looked at these equations, I also felt like, oh, the x and y variables having coefficients and the constant value is big. But when we actually solved it, it is very easy, right? So I prefer elimination method if it is not specified. In the board exam, if the question is solve this pair of linear equations, so I will straight away go with this elimination method, because in elimination method, the complexity is reduced. So the only trick that you need to use is just mark those, label those equations as 1 and 2, and multiply each equation with the x coefficient of the other equation. Then you will get another 2 equations, then subtract those. So you can eliminate x variable, and then you can find y value and substitute that y value in any equation, equation 1 or 2, you'll get x value. Okay. So this is about elimination method. So to recap, right? So what we have seen, so we have seen substitution method and elimination method. In the substitution method, so what you need to do is from equation 1 and 2, first you need to get either x or y value from one equation. Yeah, let's look at this example, right? So x plus y is 14. Then get any value, y is 14 minus x. That y value you substitute in the other equation. Other equation's y value, so you'll get x. And once you get x, then you substitute back into any of the equation, you'll get y. Okay, so that is substitution method. So the elimination method I just explained, right? But here the catch, right? So what the catch is, they just don't give this simple. In the board exam, they do Most of the times, they won't give you the equations directly. So how you solve that? So generally, they give a descriptive problem, right? From the descriptive problem, you need to derive the equations and then you need to solve those equations. So here, deriving the from the descriptive, writing the equations is key here. We will see some example, right? So let's see what is that. So here I'm just reading out a problem, right? Listen carefully. We will just write the equations and then once we know the equations, then it is easy for you, right? So I'm doing one example here. The area of a rectangle. So just draw the diagram so that don't think this is a parallelogram. This is a rectangle. I'm drawing with freehand. So the area of a rectangle gets reduced by 9 square units. Okay. If its length is reduced by 5 units and breadth is increased by 3 units. Okay. Let's say this is L and this is B. Two variables. So a rectangle has two variables, right? Length and breadth. Now, what they are saying is, what is the area of this? If L is the length and B is the breadth, then area of the rectangle is L into B. Now they are saying another rectangle where the length is increased by 5. So this L is becoming L plus 5. Okay, listen carefully. And the breadth is increased by, sorry, length is reduced by, sorry. So this is minus. So length is reduced by 5 units and breadth is increased by 3 units. So if the length is reduced by 5 units and the breadth is increased by 3 units, what is happening? The area of the rectangle gets reduced by 9 square units. So the area, what is the area? The initial area was the LB and that is getting reduced by 9 square units. So what is this area? This area is for the new length and breadth. So what is the new length and breadth? L minus 5 into B plus 3 is equal to LB minus 9. So this is one equation. This is how you need to get to the equation. So basically a rectangle is given, its length and breadth, we know. I have assumed this as L and B, or you can say X and Y or AB, your wish, right? So it is just two variables. So now if length is reduced by 5 units, breadth is increased by 3 units, its overall area is shrinking or reducing by 9 square units. So initial area was LB. And when the length is minus 5 and B is plus 3, if I product it, I'll get the new area. That new area is 9 square units less than the previous area. So this is one equation. Now, if you multiply, LB gets cut, I believe. Okay. Then you will get the equation in terms of L and B, right? So that's one equation. Now, if we increase, he has given another condition because we need pair of linear equations, right? If we increase the length by 3 units, okay. Now here, L is becoming L plus 3, increase by 3 units. And if we increase the length by 3 units and the breadth by 2 units, yeah, both the length and breadth both are increasing. So B plus 2. Then what needs to happen? Area should obviously increase. So LB, the area increases by 67 square units. So LB plus 67. So this is equation 2. So now you understood, right? So they gave the descriptive problem and now we are converting those into an equation. So this is still not the perfect equation. Then find the dimensions of the rectangle. So now the first equation, if I multiply, so what this will become? L into B is LB plus 3L minus 5B. I am multiplying minus 15 equal to LB minus 9. LB gets cut, right? So then this is 3L minus 5B equal to minus 9 plus 15. Then 3L minus 5B is what? 15 minus 9 is 6. Let's say this is your equation 3. In this form we need pair of linear equation in two variables. So here the variable is, in place of x and y, you have L and B. Now simplify this equation. L into B plus 2L. The second equation I am simplifying. Then plus 3B plus 6 equal to LB plus 67. LB gets cut, and then 2L plus 3B equal to 67. That 6 I am sending to the other side. Then 2L plus 3B is 61. So this is your equation 4. Now equation 3 and 4 are your pair of linear equations. So if you solve those, so I prefer elimination method. So you just multiply equation 3 with, what is the L coefficient here? 2. Equation 3 with 2 and equation 4 with 3. The other variables coefficient. Then you can eliminate L, you can find B, and found once you get B, then you substitute. So like how I explained the elimination method. So here in this topic, we reviewed the two different methods of solving pair of linear equation, substitution method and elimination method. And I also stressed on, you will not get the equations directly in the board exam. So what you need to do is, they'll give you as a descriptive, like the rectangle problem. From that, you need to assume the variables and then derive the equations. And those equations, if you solve, you will get what is needed. They have basically asked here L and B. Okay. All right. So that's about pair of linear equations, elimination method and substitution method. Thanks. Thank you. Thank you for your time.